Welcome back, and we continue our discussion on security protocols. And in this regard, last class we saw about what is a digital certificate, and that time I told you that digital certificates are used when somebody establishes a secure communication with a server. So, let us try to know about a protocol which we typically otherwise use unknowingly, which is HTTPS, which is a protocol which is inserted within the TCP/IP protocol stack. So, this protocol is called TLS protocol. So, this TLS protocol originally was known as SSL protocol, first proposed by Netscape. Later it is called as transport layer security protocol and used for secure communication over the web. So, this protocol basically resolves this authentication, confidentiality and non-repudiation issues. Let us see that how this protocol work. This protocol, if you remember the TCP/IP protocol stack, TCP/IP is at the top and above that you have application layer. So, above TCP and below HTTP, HTTP is one application layer protocol. So, above TCP and below HTTP lies your TLC, transport layer security protocol. This protocol has two parts. First is TLS Handshake Protocol and second one is TLS Record Protocol. It's the work of the TLS Handshake Protocol is to negotiate about the cryptographic and data compression algorithm, exchange of secret public key, generation of secret key, and before I proceed about this record protocol, let me tell you, while discussing about symmetric and asymmetric key algorithm, we learned that asymmetric key algorithms are very costly compared to symmetric key algorithms. But due to problem in key exchange, the keys are first exchanged using asymmetric key algorithm, and once the keys are shared by both the parties, then the bulk transfer can take place using symmetric key algorithm. This idea is implemented in this TLS protocol. So, during TLS handshake procedure, this key exchange takes place, and during record protocol actually bulk data transfer takes place. So, let us try to see what will happen in detail, what will happen during these protocol executions. So, let us first learn about TLS handshake protocol. Here we have already learned about how this public and private key pairs are generated by certifying authorities and all, and we are not going to discuss about it anymore. I expect that you have already gone through that lecture. Now, it is the work of the TLS handshake protocol to select the public key cryptographic algorithm, and in this case RSA is used. The key used for transmission and share of shared secret. So, the key is required here. It also helps in selection of bulk encryption algorithm DES and the session key to be used during the session by the record protocol. Then the message authentication code to be used for the record protocol. Then compression algorithm used by the record protocol, and server authenticates itself to the client, and the client occasionally authenticates itself to the server during handshaking procedure. So, basically at this stage during this handshaking protocol, the server authenticates itself and the client occasionally authenticates itself to the server. But during this authentication process, the key exchange has to take place, as well as both the parties must decide. See, if some suppose first the key exchange has to take place. So, both the parties must have to have the same algorithm to decrypt the information about the key. So, some negotiation has to happen between client and server. Similarly, when the bulk encryption takes place, the same algorithm must be present in both server and the client, whereas suppose DES is present in server and client as well, then if something gets encrypted with the DES algorithm, same DES algorithm with the shared key which is shared using this PK using the digital server information exchange procedure can be actually used for decrypting the bulk data. So, this is about the digital certificate we already know, and the servers show this certificate to the client to get itself authenticated. Now, look at the TLS protocol details. For encryption and decryption, for bulk encryption and decryption, it uses DES, TDS or RC4. For message authentication, MD5, SHA, SHA1 and so on. Similarly, for data compression or decompression, it uses certain algorithms as well. Now, let us see these steps in little bit more detail using something called a client server diagram, which we are going to use subsequently. In a typical client server interaction diagram, we will be having two nodes, one we call as a client node, this will be calling as a client node, and this will be calling as then the other nodes which will be used for various operations in between. So, you have two types of nodes, one is the client node and another is the server node. So, this client node which is used using this which we will be know using this looking at this C, and server node will be represented with S, and when the operation starts there will be a start node which will be represented as a square, and all these things will be in a circular shape. So, when the message goes from one entity to other, we will have a directed edge connecting both the entities. Now, look at this. This is a client server interaction diagram for TLS handshake protocol. So, first the client, when you will be sending a message to the server, you will first start the interaction as a client. Through your browser you are sending some message to the server. So, first you have to start the interaction. So, first the client sends a client hello message. In response, server sends one server hello message, and this with response to this server's message, once again the client sends some other message, and finally the server finishes it with acknowledging the client finishes it by acknowledging the server's message. If you look at this diagram, we have two paths. Usually during TLS transaction, as we have already told you, HTTP is a stateless protocol. So, in order to so which means if every time you make a connection, over secure TLS protocol, you have to be going through HTTP, because TLS protocol is in between TCP and HTTP. So, the message has to pass through TLS layer as well. Now, in during when this TLS operation takes place, after later maybe next class we are going to talk about what is the implication of using the security protocol on server's performance, but right now let me tell you, it is actually a costly operation. So, therefore, every time getting the server authenticated, if consecutively we are going to have a number of interaction, every time creating and sharing the symmetric key using private key public key operations is a pretty costly activity. So, therefore, at the server and at the client's end some session will be maintained, and within that session, within that time period, if another secure message comes, then the old symmetric key which was originally generated can be used. So, if that particular session is still there, then there is no need for this key exchange again. So, therefore, this during handshake procedure two paths can be followed. If the session is maintained, then this can be directly sent. If the session is not maintained, the key exchange once again has to take place. Now, each of these messages that we saw just now, client hello, server hello, etc., let us see what all is included there. Client hello message, through the client hello message, what you send is a random number generated by the client, the time measured at the client, a session ID, a cipher suit, because now both the client and server are negotiating, because during symmetric key operation they are going to use the same cryptographic algorithm, same what do you say that data compression algorithm, etc. So, therefore, the cipher suit which is a name for the set of encryption algorithms and the other stuffs which is supported at the client side is sent to the server. Client now says, I have these facilities. So, therefore, while sending the data in encrypted form, you have to use one of these algorithms, so that at my end I can use the same algorithm to decrypt it. So, it also sends some protocol version and total 68 byte it sends, but that is not important. But again, from during server hello message, what the server does, server will be authenticating itself, and while talking about this digital certificate, we know that digital certificates are issued by certain certifying authority, and they are used to authenticate a server. So, server will be sending its digital certificate. Digital certificate contains many details about the server, including its public key. Then client send one random number, server will send another random number to the client. So, client will have his own random, client is now having his own random number plus server random number. Similarly, server is having client's random number which is sent during client hello message and his own random number. And it also let the client know the cipher suit supported by itself and the compression method supported by itself. So, once the server send this message, then client will authenticate the server using the server certificate. So, what it will do? It will verify the certificate, and about digital certificate verification we have already discussed last class, that how the digital certificate gets verified. So, now this after the client verifies the digital certificate, the client generates a pre-master secret and key to be used for bulk encryption. And how this key gets generated at the client side? Using some pre-master secret, server random number, client random number, and this pre-master secret is available at both the ends. So, this pre-master secret, server random number and client random number are shared, then it encrypts it using server's public key. Where from it gets server's public key? Because server has already sent his public key during certificate, while showing his certificate during server hello message. So, using all these three things, it will now create a key, and this key will be subsequently used by the during the bulk record TLS record protocol, which is for bulk transfer. Now, server receives this client key exchange message and decrypts the pre-master secret using its private key, because it is now encrypted with his public key. See, public key is already sent, the pre-master secret which is generated by at the client side. See, previously both the random numbers were shared. Now, a pre-master secret which is about which algorithm etc. to be used is now shared with the server. So, now this pre-master secret nobody can see, because it was encrypted with server's public key which was already sent to the client. So, therefore, using both the random numbers and this pre-master secret, now the server creates the bulk transfer key at its end, because both the entities use the same information for creating the key. The key need not now to be explicitly transferred. What got transferred? Transferred two random numbers, then certain using this private key operations, some pre-master secret which is about the algorithm etc. is shared to the server. So, the key gets generated at both the end, both at client and server end. As I was telling you, this whole process involves many cryptographic operations, many security operations, so which is bit costly. So, if see during this transaction some session ID was getting generated, that I told you. So, if the session ID has a life, within that time period if further transactions continue, then the same session continue, then the same key which got generated previously can be used. This will actually decrease some load for encryption load from both client and server side. So, the client sends the in this particular path, if we are going back, we were talking about two paths for handshaking. So far we have been talking about this path, and just now I told, if the session IDs are maintained by both client and server, then this particular step which is for key exchange can be bypassed. So, if the session IDs are cached, this can benefit the transaction in terms of time. The client sends the old client session ID if it wants to reuse it, a new random number and other details to the server. If the client session ID is cached at the server, then server sends back the same client ID in place of the server session ID, a new server random number along with the other details. Client conforms with the client finished message, and both now can continue using the same, you can continue with the same session. Now, what is the overhead due to TLS? This overhead due to TLS is because of the increase in the round trip time. By round trip time we mean when, see, look, at the time of TCP interactions you had one three-way handshaking procedure. So, client connects to the server, server gives some acknowledgement, then client starts sending the data. During TLS again you have another once again you are carrying out some kind of handshaking procedure for generation of the symmetric key and for the server certificate verification and generation of the symmetric key. So, for this some some overhead is incurred by the server as well as the client, and the processing time increase. So, next class we are going to see how exactly processing time increases through one example, but let us try to understand what is that additional time taken at the client's end. Client takes time for handshaking, for decrypting the message, for verifying. At the server it is handshaking, encrypting the message and generating the message digest. This thing again, this handshaking time, handshaking which again involves this encryption decryption is what? Decryption and verification is what? This is for the bulk data, but handshaking is for key generation. So, key generation takes place plus bulk data transfer takes place. For both these now some time is consumed. This handshaking is again has many steps: verification of server certificate, encryption of master secrets with server's public key, bulk encryption, key generation from these master secrets, then the processing at the server which is about handshaking at the server side, and then encryption of what? Encryption of the bulk data, encryption of the bulk data along with the message digest generation. This is for your record protocol part, this is for your handshake TLS handshake protocol part. And here the what is the handshaking time? Decryption of the master secrets with private key, bulk encryption, key generation from the master secret at the server end. So, all these times taken together adds overhead to TLS. Now, at what factor it actually increases, that we are going to see in the next class. Thank you very much.